Hi, to start today, I'd like to try and solve these two quadratic equations, giving any reasoning throughout. So the way that I've taught this, and there is more than one way which we'll be looking at, is to try to factorize it. So double brackets equal to 0. We're going to need an x and an x to get the x squared term, and then two numbers that multiply to give minus 6, add to give minus 1. That's going to be minus 3 and plus 2. Sometimes I see people then just write down the solution straight away. X equals 3 or minus 2, which is correct, but give reasoning. Where did that come from? It comes from the fact that I am multiplying two things together to get 0. So the only way I can do that is if one of the things itself is 0. You can't sort of have 2 times 3 or 2 times some other non-zero number and get 0. You're going to have, it's going to be greater than 0, or, well, if it's negative, potentially less than 0. So here, one of these must be 0, basically. X minus 3 equals 0, or x plus 2 equals 0. Maybe you show this step every time. It's just worth remembering, because you can jump straight to the answer. You just basically flip it around, the sign, when you solve these equations. But make sure you understand where it's come from. In the second one, it's the same idea. So this time it's x. Okay, got to multiply to give 6, add to give minus 5. They've got to both be negative to get the minus 6. Sorry, the plus 6 rather. So it's going to be minus 2, minus 3. That will make it work. Set it equal to 0. And this time, okay, I would have to show that step in red. X minus 2 equals 0, or x minus 3 equals 0. Alright, I've explained it this time, so I'm okay just writing 2 or 3. Hopefully you're happy with that. Because today we are moving on to forming and solving quadratics. It's the first lesson on it. And sometimes quadratic equations need to be rearranged to get them into a familiar form to solve. So here I've actually got a much more complicated expression than the ones I gave you. We've got 2x squared, we've got x squared. How can we solve this? Well, here's how. We can rearrange it to get it equal to 0. And we can minus x squared from both sides, which gets rid of it from the right hand side. That's what's happened here. And now what do you think is going to happen? We're going to minus 5x from both sides, and that gives 4x minus 5x, which is just minus x or minus 1x. That's now equal to minus 3. And then finally add 3 to both sides, which gives x squared minus x minus 6 equals 0. And we're back to where we were in that starter, but we started with something more complicated that we've had to turn into a quadratic that equals 0. After that, factorize and get the solution. So now that I've explained that, basically get all the terms on one side. I would advise you make it so you got x squared as positive. If it's negative, then get everything else over to the other side, so it is just x squared by itself. Otherwise, you're going to get into more difficulties. So have a go at these 4 questions here that are all slightly rearranged. I'm going to show you the answer. So you should be able to rearrange to this, factorize to this, and solve to x equals 4 or 2. Second one, minus 10 from both sides, add 2x to give this, factorize and solve. Stepping up in difficulty here, we're going to have to minus 5x squared from both sides, and minus 4, which gives that, and we get 7 or minus 2. And finally, this one looks really complicated when you first look at it, but when you think about what we've just been covering, just get them all on one side, and actually it factorizes nicely again. So we can now deal with these quadratics. We have to be able to recognize but it's a quadratic. Sometimes you might even get them like this, x, I don't know, x plus 4. You know, it might not obviously have an x squared in it, but you've got to sort of look at it and think, okay, yes, I'm dealing with a quadratic here. Going to get the method for how to solve that sorted. Right, just a little question. Lisa tries to solve this equation. Here's her working out. Her working out's incorrect. How should she have solved this equation? So really, she should have done this. Get it all on one side, factorize it, and actually you should get two solutions, 0 or 7. To be fair, her working is nearly okay. It's just because she's divided through by x. And when you divide through by x, you're basically ignoring any solution of x equals 0 because you're not allowed to divide through by 0. So she's got 7, she's lost the solution x equals 0, which really she should have got at this stage here. It will be this or x equals 0, because if x equals 0, she's not allowed to divide by x. So technically, there's nothing like majorly wrong with her working, except that she's missed a solution here. If she put that in, it would be okay. These two would be correct. Best advice, though, is to rearrange it into a quadratic and solve it, and then you'll make sure that you won't miss that x equals 0. Here goes then. This is sort of the main bit I want to get onto now, forming and solving quadratics. The length of a rectangle is 4 centimeters longer than its width. The area is 96. Find the perimeter of the rectangle. So it looks quite complicated to start with, but let's get that rectangle sketched out. And the length is 4 centimeters longer than the width. So I'm going to call this one the length and this one the width. So the width, I don't know what it is. Maybe I give it a symbol. Maybe I call it x. No, I'll call this one the width. And the length is 4 centimeters longer, so it's going to be whatever x is, and then you actually add on 4. And the area of this rectangle is 96. So we can write down a quadratic equation. It might not look like it to start with, but it's going to be, I'm going to do the the height times the base. So x plus 4, I'm just putting the x on the left, equals 96. And I've created a quadratic. I'm going to expand it out, x squared plus 4x equals 96, but I'm going to straight away minus 96, because that will leave me with a quadratic equation equal to 0. Now we need to find two numbers that multiply to give minus 96, add to give 4. They're going to be quite close together, and actually it helps if you can remember that 96 is actually 12 times 8. So it's going to be plus 12 to get that plus 4x there, and then minus 8 here. Right, we're not quite done, we now need to solve it. So x must equal minus 12 or 8. We seem to have two solutions. Find the perimeter, we haven't quite done that yet, but there's an issue here. Because we're dealing with the length of a rectangle, we can't actually get a negative, so we need to reject this one. We do need to state that. We shouldn't just cross it out, we should literally say reject. So x equals 8, and then find the perimeter. It's going to be 8 plus 8, my two heights, plus x plus 4 is going to be 12, because remember x is 8, plus 12. 12 plus 8 is 20, so I've got two lots of that, so I'm going to get 40. It's going to be 40 centimeters, and we've solved this problem. Brilliant, constructing a quadratic and then solving it. Here's a little diagnostic question. The area of this shape is 82 square units. Which of the following statements is correct? So it makes sense to work out each individual block. This one's going to be 3x squared. This one's going to be 4x. and this one's going to be 9x. If we add those together, we get 3x squared plus 13x. And that is equal to 82. Actually, we see the answer right there. So we can construct a quadratic. In this case, we're not being asked to solve it. We've actually, as I write this, we've not covered these sorts of quadratics with a 3 in front. We need slightly different methods for that. Here's one more then on creating and solving a quadratic. This is kind of a classic problem, not just looking at the area of a shape, but bringing in things like surface area. We're told the surface area, and then we're asked to show a quadratic equation is true. Now, where does that come from? Okay, let's think about this. We can find the surface area in terms of x, and then maybe equate it to 3,600 and turn it into that part A. We've opened out the cuboid here with the net, but I think I'm just going to kind of shade at the front and the back and so on as I need to. This here then is the front, and that has a x plus 15 base and a height of x. So it's going to be x plus 15. But I know the back is exactly the same, so I can put a 2 in front of it. This is the front and back. Next, I've got the sides. So I've got the right-hand side and I'll have the left-hand side as well. So if I add that on, I'll get x squared for that side. Because I've got it on the right and left, it's going to be 2x squared. And that's going to be the left-hand side and the right-hand side. And then finally, we've got the top, which is also x times x plus 15. And the same with the bottom. I'm going to write it out here for the time being, so it's going to be again 2x, x plus 15. And I can set that equal to 3,600. We've created an equation. We just need to show that it reduces to this, x squared plus 10x minus 600. All right, well, I think the first thing to do probably is divide through by 2. I can divide that term by 2, that term by 2, that term by 2, and this one by 2, all in one go. Then what am I left up with? I think I might just expand it. Actually, these two are the same, but I'm going to expand it separately. I'm going to get x squared plus 15x plus x squared from this red term plus x squared plus 15x equals the surface area, 1,800. Well, it's not the surface area anymore. I've divided through by 2. I'm nearly there, actually. It might not look like it, but I can simplify this to 3x squared because I'm adding all the x squared terms plus 30x equals 1,800. We got there. Nearly. Now we just need to divide through by 3. It's a common factor of 3. We can see in the answer there's no 3 in front of the x squared, so it's going to be x squared plus 10x equals, oh no, not equals, I'm dividing through by 3, so it's going to be 600. I can minus 600 from both sides, and then I've done what the question's asked. That is going to equal 0. Okay, that took more space than I thought. To find x, we're going to set that equal to 0. It's going to be, and then factorize it, which becomes two numbers that goes into 600 that only differ by 10. It's going to be 20 and 30. So it's going to be plus 30 to get that 10x and minus 20. That's going to equal 0. So x is going to equal minus 30 or 20. And x can't actually equal minus 30, so we're going to reject that one. So x equals 20. And then finally, the volume, this is part C, the volume is going to equal 20 times 20 times x plus 15, so times 35. And I'm not sure what that actually gives. 14,000. Okay, that's what I did earlier. That looks about right. So we can find the volume of the cuboid as a result. Whew, quite a lot going on there. Okay, it's creating a quadratic. There's little sort of hints, tricks I've done on the way. Try and divide through by common factors. Even after I divided through by 2 and collected everything together, I still then had to divide through by 3. So you could wait until the very end, but sometimes it's just easier to simplify if you kind of do it as you go. So what I'd like to do is practice this some more. That's the main bit of the lesson from now on. I'm showing you the answers here, but there's a task that I will have a go at it. Really give this a go. Can you rearrange quadratics? Can you solve quadratics? Can you reject solutions? Can you form quadratics? Go for it. So answer to number 1 is as shown. Construct the quadratic, we write it in a nicer form, and we factorize it, we solve it, we work out the perimeter. Similar to the triangle, but it's half base times height, same process. Solve the quadratic, reject the negative solution. Base is 10, height is 17. Number 3, get this written down in terms of x. So there's 2 ways you can split your shape, or 2 clear ways. You might split it that way and work out the compound area, or you might split it that way and work out the compound area. They'll lead to the same equation. You actually get x squared plus 8x minus 65 equals 0. Factorize it. 2 solutions, reject the minus 13. X is 5. Work out the perimeter, 36. Brilliant, we got that. Onto surface area. Similar sort of thing. This time with x plus 6. Get a quadratic. Make sure you practice this. Find x. Find the volume of the cuboid. X is equal to 5. The volume is 275. Another cuboid one. This time, we've got 3 different sides. The volume's 5,000, so there's quite a bit to do here. Just be careful that you're using the volume idea to get it. Actually, maybe slightly nicer than the surface area. Once you've got this quadratic there, it doesn't look quite as nice to solve. However, you can by dividing through the common factor of 2. This gives this. Get these as factorized, and x equals 25. And that is the length of the cuboid. And then some challenge questions. Calculate the size of this triangle. Sorry, the side lengths as numbers. Well, there's nothing given like area or anything like that, perimeter. But we have a relationship between the sides, and we know there is a relationship between the sides of any right-angled triangle. This is Pythagoras Theorem. You have to expand double brackets. You've got to realize that you're doing x plus 2 all squared, which is actually a double bracket. Multiply it all out. Manipulate it. It will actually simplify down to this, which factorizes, and then you get 6 as your answer. 6, 8, 10. This is a Pythagorean triple, in fact. One more. So again, Pythagoras' theorem, it simplifies to what they ask you to do in part A now. Solve that for x, 7. Find the area of the triangle using half base times height. There we go, 7 questions. If you put the time in there and effort, then hopefully you're in a good place. You're happy forming and solving quadratics, manipulating them when they're not equal to 0. Always try and get them equal to 0. Well done.